Okay, let's do this question, guys. So we were doing this question, and I think we can do this by DFS, right? All right. Uh, like if we can move from this to this, so we will have start array and we will have end array, and private, right? So it's a board is of 8 by 8, so 0 to 7 it is, right? Okay, all right. So f is like start, or we can say just x variable y, and then we will have target. Okay, vector of enter and target like this. And what we can do from here is this, like if x comma y, okay, if x is equal to target of 0 at y is equal to target of 1, in this case return true, right? And we take this here, okay, and we take this like, okay, for int I is equal to 0, I less than 8, okay, I plus plus, and we can say int new x is equal to x plus dxi, right? And int new y is dyi, right? Like this. And we will check the condition. If new x, okay, is greater than 0, okay, greater than equal to 0, and new x is less than 8, and new y is greater than equal to 0, and new y is less than 8. In that case, we check f of new x comma new y comma target, okay, like this. We return this here from here on, okay. We can do this. If everything fails in this case. Return false, right? And in this case return f of start 0, which will be x, and start y, target, right? I think it should work. Oh, it's not like this. Vector of int, right? Wait. Int. Okay. Whatever. 3, 4, 5, 6, 7, 8 it is. Okay, what's the problem? What's happening? Right. 4, 5, 6, 7, 8. Correct. 1 minus 1 minus 2, 2 minus 2. It's looking good here. 2 minus 2 minus 2. 1 minus 2. What's the problem? To me it's looking good. What? Deadly signal cat 25. Take over, hello. I don't know what is this. X underscore and Y underscore. Is this a problem? Underscore X underscore Y. Here underscore X. It's also underscore Y. Okay. Yeah. Alright. What's the problem in this line? Now what's the new problem, brother? What? Oh, okay, so let's do one thing. One thing, I need this visited array, okay? Visited vector rule, right? Visited comma vector of rule 8 comma false, right? And we pass this visited also. Take this visited from here. To here also, right? It is true, and visited x comma y equal to true, right? And this and not visited new x new y, right? Then only if this return true, else it will false. Let's check it now. Vector rule. Okay, so I need to pass this visited also here also, right? Now what is it? Vector visited 8 comma false. Now what is the problem? Oh, okay, so I think it's try to submit. wrong answer after this. Okay, so here start is 4 5 and target output is true or expected is false. Okay, whatever. Think I need to do this. If any problem there, right? Oh, wrong answer. Right. 452 6.6. Right, it's oh, so we need that thing also. Okay, so even number of moves is there. Must remain the same. Therefore, start text mode y is equal to that mode also must be same. Okay, so the one condition must do return start okay, so start 0 plus start 1 move 2 is equal to okay, so it's just that simple, this simple here, no need to do anything. Okay, let me try this. Let's set up this. What are we doing? Wow. Next problem. is this. You are given the root of a complete binary tree. Okay. A node x is called dominant if its value is equal to the maximum value among all nodes in the subtree rooted at x. Return number of dominant nodes in the tree. So let's take this and take it here, right? Okay. So as you can see here, dominant node is all the a node x is called dominant. It's a complete binary tree also. Okay. If its value is equal to the maximum value among all the nodes in the subtree rooted as x. So in this example, output is 5 nodes are there like this. Okay, so let me have the leaf node with values, all of them are dominant. Okay, and 8 also. So in this case, if it is a complete binary tree, all the leaf node so complete binary tree is what? So we need to count these leaf nodes, right? All the leaf nodes and all the dominant nodes. Okay. So when we try to root value, okay, we will have the root value and we explore the tree left and right, and we get the maximum from that. Okay, if maximum value is less than or equal to the root value, then we increase the count plus. Okay, like this. This will be the easy one. Order of n it will be, right? Okay, so let's try to do this. Okay, so we will have this function. Okay, and let's say and f like this, and tree node take root, and if root is equal to null pointer, right? In this case, return int min. Okay, in that case. Alright, then we will have this variable int Okay, we have to count all the variables, right? Okay, so int value is equal to root well, right, like this. Okay, and maxi is like int min here, right, and the left is equal to f of root left. Okay. And int right is equal to of root right, and maxi is equal to max of left comma max of left comma right, and maxi right, and if maxi is less than equal to well, then we count plus plus, and this count will be public, right, and to count is equal to 0. Alright, so like this, and void f of root return count. Okay, let's try this. Return what is it? Okay, okay, let's return int min. Okay, and there is return count like this. Okay, and you just can return from here. Okay, so for first it's saying 6, but output is 5. Okay, and for second it's saying 4, output is 4 also. Or why it's saying 6 for this, right? 5 3 8 2 4 7 1. Return maxi. Alright, and f and return count. Do I need to do this? 7 now. Okay, wow. Here 5. What's the problem here? 4 6, but it should be 5 here, right? Let's check what is the problem in this. Okay. Okay. Oh, one problem I found here, guys. I think here I should go for when, right? And here I should go for maxi. Oh, accepted. It's accepted here, right? The problem was there only. 5 here and 4 here. It accepted also. Okay, we have done this. Let's do the transform binary string using subsequent sort. Oh, what is this subsequent sort? So this question is transform binary string using subsequence sort. Here you given a binary string, okay. You are also given an array of strings, strs, okay, where each str's I has same length as s, okay, and consists of character 0 and 1 because it is binary, and question mark also, okay. Each question mark can be replaced by either 0 or 1. Alright, so you may perform following operations any number of times, including 0 times. Choose any subsequence of s, sub of s, sort sub in non-decreasing order, and replace the chosen subsequence of s in the sorted sub, keeping all other characters unchanged. Return Boolean array answer where survey is true if it's possible to replace all 0 in str's I with 0 1 and transform s into resulting string using the allowed operation above. Otherwise return false. So let's take this example and how it's explained. Okay, so you have this example, right? Like this. Let me change the color. Okay, now as you can see here, we have a string s which is 101, right? And we have array of strings this. When we need to perform true, right? So when we can perform true is this. There are some rules. You are given also array of strings str where each str has same length as s, okay, and consists of characters 0 and 1, right? And there is question mark also, and each question can be replaced by 0 and 1. You may perform following operation any number of times, including 0 times. Choose any subsequence sub of s. Okay, so we can choose any subsequence of s. Okay, and sort sub in non-decreasing order means increasing order. Okay, and replace the chosen subsequence s with the sorted sub. Okay, keeping all other characters unchanged. Okay, return the boolean array answer where answer I is true if it's possible to replace all question mark str's I with 0 or 1. Transform s into the resulting string using the allowed operation above, otherwise it is false. Okay, so okay, that's not that hard, right? I understand it now. What is the problem here? Nothing, right? Let me tell you. Correct. Okay, so what we need to do, we are here, right? 101 like question mark, we can replace it with we can make it 101 or we can make it 111. Okay, now if we have s this, okay, we will take subsequence of s, right? If this matches with this, it is true, right? and we can take the subsequence of s and we sort that subsequence, right, and replace that subsequence whatever we got, and then again check, like let's see this thing, right? You can make it 0 0 1 and 0 1 1, right, and s is 1 0 1. Now to achieve, I think we cannot achieve this because we have only 1 0, right? We can achieve this. Then if we can achieve this, then how can we achieve this? We will choose a subsequence of this from this. Let's choose this, okay, and sort this, then will come 0 1. We choose this part and sort that and replace with this part. This becomes 0 1 1, and it is equivalent to this, right? And 0 1 0, because it has two zeros, we cannot have these two zeros, so we cannot replace it. Then this is false, right? So can you see the pattern? So number of zeros, right, so if we have like more characters, okay, so if we have number of ones here more than number of ones here, or number of zeros here more than number of zeros here, then we cannot do that, right? Because we just can add, we cannot subtract. So if we just count the number of zeros and number of ones, right? So that's the okay. So is there any long example? Example 2, yeah, this is good. Let's take this example. Well, and subsequence is like very vast thing. So do we need to check all the subsequences? That's also the problem, right? Let's try this subsequence, because if it is not solving with this trick, then we are in very so 1 1 0 0, and this is 0 0 1 1, it's equal to, then it's true, okay. Then if we have this 1 0 0, right, so it's also, because if it is equal, right, if it is equal, then there is a possibility like we can choose any subsequence and sort it in any number of times. So the only possible case when here we have more zeros or more ones than here, more the number of ones, number of zeros, right, then in this case it is false, otherwise it's always true, right? So we just need to count that, I think. Okay, so let's just try it. Okay, and s0, right, is equal to 0, and s1, how many ones in s, right? Okay, one more thing. Now let's take for loop, and I is equal to 0, I is less than s dot size, right, I plus plus, right, if si is equal to 0, then s0 plus plus if s of I is equal to this is character 1, right? S1 plus plus. Okay, we have this. Now for int I is equal to 0 and I is less than str's dot size, right, and I plus plus. Now we will have this one more thing, str string st is equal to s of str's I, right? So from here for int I is equal to it will be j equal to 0 less than st dot size, right, j plus plus. And one more thing is here one more thing is int st0 is equal to 0, int st1 is equal to 0. Okay, and if st of j equal to 0, okay, then st0 plus plus. If st of j is equal to 1, right, then st of 1 plus plus. After that, if st0 right less than is equal to s0 and st1 is less equal to s1, right, then in that case if it is there, then answer of I is equal to true, right? Okay, and we need to take this one more thing also, vector of int answer, it's not int, it's a bool, answer of dot size false. Okay, here we can return answer here, right? Just trying, guys, just trying. True true false in first case, right? True true false in second case, true false true, or what? True false true in third example. What is third example? It's true. Yeah, I think it should be like this. Wrong answer right here. Okay, true output is true, expected was false. Okay, so if I am choosing this 0 1, right, and I just to choose this 0 1 and sort this subsequence like all array and choose here 1, it should be true. It's possible. Why it's false expected here? I don't know. Right, let's check. Control C. And one more thing, why it is wrong answer here in this case, right? and let me tell the description of the problem also, right? This is the description. So searching if the target has the most as many zeros, then it is possible. This assumption is correct because this allowed operation is not arbitrary rearrangement. So you can choose any subsequence and sort it. Okay. Sorting means this. Notice something important. A can move to the. Oh, yeah. That was a problem, guys. That's the problem. We were not able to found that out, right? But one can never move left, right? Zero can move never move right. So this order is only partially changeable. Yeah. That's correct. So this can never become 0 1 can never become 1 0, right? What property must hold? Suppose 1 0 1 0 is there. Every operation only pushes zeros to left and ones to right. Okay, so every prefix, the number of ones in the largest target cannot exceed the number of ones in the original string. Okay. Alright, so that was the problem. Right. Now let Si probability of Si is P of Si. Okay. Number of ones in first I text characters of S. Text number of in first I text character of target. Okay. Then probability of target is I is less than equal to probability of. Then because we cannot move left into an earlier prefix. For example, S is equal to 0, 1. Prefix is 1. S is equal to 0 once. S is equal to 0, 1 is equal to 0. Target is 1, 0. So in this prefix, so now impossible, it is impossible. Okay. Exactly why the answer is false, but there is a question mark characteristic. Now we choose the question mark optimally. At every position, question mark can become 0 or 1, right? So while scaling left to right, we should assign x. So that's the set of the total number of ones, every prefix constraint, right? Simply comparing total counts is insufficient. Okay. So why our logic fails immediately? Because you checked zeros is less than zeros and ones is less than. That are necessary condition but not sufficient. For example, 0, 1 like this. Okay. So the transformation is this problem requires using prefix invariant handling, not just comparing the total number of zeros and number of ones. Okay. So let's try this prefix thing, right? So I think what we were doing is 0 plus plus and s of 1 plus plus, right? And now what we will choose here, not here, right? Okay, so this is very not very good thing here. We take these also from here, right, for prefix thing. See, we can just control x from here and put them here, right? And we check if s of j, right, j is equal to 0, then s0 plus plus. If s of j, right, is equal to 1, then s of 1 plus plus. Now in this case, what we choose is if, okay, we are at j, if st of j is equal to question mark, in that case if number of ones in here, number of ones in the prefix also only, right? Number of ones if s1, right, minus st1, if the difference or we can say number of ones in okay. Number s1, number of ones in s, prefix there, and number of ones in number of ones must be always greater than this. So if the difference is only 1, right, equal to 1, right, so we can say less than equal to 1 if difference is like this. Okay, then flag equal to true. Okay, else flag equal to false. Alright, if it is like this, if it is not this, else if s1, okay, minus st1 is greater than 0, or we can say s1 minus s1 greater than 0, then flag equal to false. Okay, else flag equal to true. Just think like that. False. And flag, right, whole flag is equal to false. We just do here. Okay, whole flag is equal to false. Just check. Expected is not available, but it should be true, right? False, false, true, 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 false. It's everything. ST1 and this is SIP. Let's try this. True, true, false, 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 true, false. Okay. Let me do this vector int st, right, of size s dot size comma 0. Okay, and I will go for int I equal to 0. I less than s dot size s plus if s of I equal to 1, then count plus and st of I is equal to count and c and t equal to 0, and st is what? It should not be st. S1. So S1. Okay. We will not do this here. This. S1 J. Okay. S1 J. Let's try this. Let's again false, false, false. Everything is false right now. Let me get my solution here. Right direction by thinking of prefix counts, but there is several mistakes in your manipulation. Big S tail SI1. Here SI is a character, not an integer. Okay, so you always false. So count A0 is never computed. Okay, A0 is and S1s are never computed. You wrote but never updated them, and later okay becomes previous condition is wrong. So from 1 in target fix less than equal to once in source prefix, that is okay. There is no plus on any bus, so not immediately increase, decrease anything. Suppose targets at your you don't get any because you become 0 and okay. Sure, okay, or flag gets overwritten. Suppose valid true level Once a break is already conditions, answer should remain false. Break. Total once okay. Okay, so let's do the we can do in this here, right? From here we can take Rolex and trophy count plus right and s1 plus else s0 plus else okay. And what one more thing, flag thing, right? Okay, so this should be st1 is equal to okay. Let me do this. If st of j st0 or we can say 1 is greater than s1 of j, then flag equal to false. Your flag is true in initialization, right? If it is not possible, then false, false, true, false, 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 okay. Now is there any problem? Oh, that one problem, it should be character, okay. We are ignoring question mark. If that means stone is not fixed. Example, field size stone is 0. Okay, if st of j equal to question mark, right, then stq plus plus, and we will have this into stq 0, right. First I need to change this also, whatever it is. Okay, so problem we are facing here is this, right? Like 2 is less than equal to 2, first is immediately, but you haven't decided what to become. Okay, just give me solution, okay. So greedy plus prefix in a variant problem. In night, actually, for this problem, we run this string. Operation sort any subsequence. Can only move 0 to left and move once to right. Okay, therefore, for every prefix, once in target prefix should be less than equal to source prefix, right, and must always hold. Observation 2 is total number of ones never change. If s is equal to 0, 1, 0, 0 contains 3 ones, then the final string must also contain exactly once 3 ones. How do we handle question? Suppose s is equal to this and this is here question mark query. Known ones is equal to 1, question marks 3. Okay. So total ones needed is 3. Therefore, need 2 ones. Okay. Again, 2 of the question mark must become 1. Scan from left to right. Then we see there are 2 choices, 0 or 1. Always try putting first. 0 first. Okay. Why? Because putting 1 increase prefix once, making the prefix condition harder, right? So only place a 1 when we must, because otherwise we won't have enough position left to place all required ones. So example this need 2, right? There are 3 question marks. Position 1, remaining 2, need 2. We can place 0, yes, so we can place 0, 0, 1, 0 is there. Need is still 2, exactly. Next is 1. Need 2 impossible to postpone, must place 1, and need 1, last place 1, done. So algorithm for every query, count fixed ones, count question marks and compute this. Okay. Answer is false. If need is less than 0 or need is greater than question marks, answer is false. Otherwise, scan left to right, maintain prefix ones, remaining question marks and need. When we can question, choose 0, unless remaining less than need, then choose 1. After every position, check prefix less than, evaluate false, otherwise true. C++ code is this. Size is there, prefix n, total 1 is 0, and total 1 prefix to 0, total 1. Okay, bool answer, string lt str, fixed 1 0, q is 0. Okay. For character C in T, C is equal to 1, prefix to 1 is 0. If C is question mark is plus plus. Need is equal to this. If need is less than 0 or need is less than Q, another push back false and continue. Right? Bool okay is true. Prefix is 0. And 0, 0, T is equal to 1, prefix 1. Else if question mark remaining is equal to Q minus minus. If remaining Q less than need, the prefix 1 plus plus, need minus minus, greater than false, break, answer correct and true. So very good solution, right? I think this is a very good solution here. Let's try to submit it, accepted, right? So good solution it was, right? Okay, next question is minimum number of string groups through transformation. Let me see this question first.
सक्सेसफुल सफलतापूर्वक हैंडल किया गया और उसका रिजल्ट निकलने में कोई डर नहीं किया। तो दोबारा इस तरह का पेपर ना हो इसके लिए सख्ती से
स्टूडेंट्स के साथ जो
सक्सेसफुल सफलतापूर्वक हैंडल किया गया और उसका रिजल्ट निकलने में कोई डर नहीं किया। तो दोबारा इस तरह का पेपर ना हो इसके लिए सख्ती से कदम जो उठाया गया है, जिन्होंने पेपर लीक धंधे में